What is going on, guys? Don checking in. Welcome to MIT, where we bring nursing to you. So to all of you who are new to this channel, welcome. If you haven't already, smash that like and subscribe button because it really does help this channel a lot. So today we're gonna do drug calculation. So get your notes and your calculators ready because I'm ready. Let's go. Hi guys, so today we're going to do drug calculation made easy. But before we're going to do drug problems, I am going to make a disclaimer here. For you to effectively do drug calculation, whether at school or at work, you must be familiar with the basic conversion table. Here's the most common conversions you're going to encounter. This is not all, so make sure you get familiarized with the others. That being said, let's get going. So the method that we will be using for our drug calculation is the unit cancellation method. So what exactly is unit cancellation method? Well, in this method, we are simply going to plot our given values in a way that we are able to cancel out units, so we will be left with the unit of the answer the problem is asking. This is easier when we apply it to a problem. If Mr. Jones weighs 65 kilograms, how much does he weigh in pounds? Now, for every problem that we have, the very first thing that we're going to look for is what is the problem asking us? What is it looking for? So in this problem, it would be pounds. Now, the next thing that we're going to do will be to write down what is given in the problem. 65 kilograms times, now we're going to look at our conversion table. 1 kilogram is equal to 2.2 pounds. And the way we are going to write that down is 1 kilogram, 2.2 pounds. So we are writing it this way because now we are able to cancel kilograms and kilograms. So we are going to be left with the unit pound. And this is what the problem is looking for. So now let's do the math. 65 times 2.2 divided by 1, that will give us 143 pounds. Let's move on to the next problem. How many ml are there in 1.2 liters? So again, we are going to look for what the problem is asking. In this problem, it is looking for ml. Now let's write down what is given to us. 1.2 liters, multiply that to the conversion table here, which is 1 liter is equal to 1000 milliliters. And this is how we're going to write it down. 1 liter is equal to 1000 ml. Now we're able to cancel liters. So we're going to be left with ml, which is what the problem is looking for. So when we do our math, 1.2 times 1000 divided by 1, that will give us 1200 ml. You are asked to administer 1 milligram of morphine sulfate. On hand is a 1 ml vial which contains 2 milligram of morphine sulfate. How many ml are you going to give? As always, let's find out what is this problem looking for. In this case, it is ml. Now we know what the problem is looking for. Now we're going to plot in what is given in our problem. So the order is 1 milligram times the other given is for every ml, it contains 2 milligram of morphine. So we can write that down as 2 milligrams is equal to 1 ml. Now, using the unit cancellation method, we can now cancel out milligram and milligram here. Let's do the math. 1 times 1 divided by 2, that will give us 0.5 ml. The order is to give 25 milligram of a medication. If on hand is 25,000 microgram of the same medication per tablet, how many tablets are you going to give? As always, let's identify what the problem is looking for. In this case, it will be tablets. Now, let's put in our given. The order is 25 milligram times. Now, we have two different units here. We have milligram and we have microgram. Now, you have two options here. You can either convert the 25 milligram to microgram, or you're going to convert 25,000 microgram to a milligram. Whatever you decide to do, it's going to give you the same answers. So for this problem, I choose to convert milligram to microgram. So I'm going to look at my conversion table. 1 milligram is equal to 1000 microgram. So we can write that down as 1 milligram is 1000 micrograms. Now we can cancel milligram, milligram. Now that gives us microgram. And then we're going to put another times. Now we're going to put in the medication we have on hand. And in this case, it is 25,000 micrograms per tablet. We're going to write that down as 25,000 microgram per tablet. This way, we get to cancel micrograms. With all the cancellations that we did, we are now left with the tablet that the problem is looking for. Now let's do our math. 25 times 1000 times 1 divided by 25,000, that will give us an answer of 1 tablet. The doctor ordered 0.3 milligram per kilogram of a drug for a 65 kilogram patient. If you have a vial that is labeled as 1 ml per 10 milligram, how many ml are you going to administer? Round to the nearest tenth. So the very first thing that we're going to do is let's look for what the problem is looking for. It is looking for ml. Now, I know this problem has a lot of numbers. Don't let it confuse you. Let's just remember that the way we're going to write down what is given in the problem is we're going to situate our numbers so that we're able to cancel out units until we are left with the unit the problem is looking for. And in this case, it's going to be ml. So let's write down the first given, 0.3 milligrams per kilogram. Multiply that to 65 kilograms. Now we're able to cancel out kilograms. And then we're going to put multiply. We're going to put 1 ml per 10 milligrams. Now we can use unit cancellation method. We get to cancel milligrams and milligrams. Now we are left with ml. Now let's do our math. 0.3 times 65 times 1 divided by 10. That will give us approximately 2 ml. It's actually 1.95 ml, but we're rounding it to the nearest tenth, which will give us 2 ml. The nurse is to infuse 1000 ml of IV fluid at 125 ml per hour. How many hours will it take for the nurse to change the IV bag? Again, what is it looking for? How many hours? Now let's write down what is given. 1000 ml, multiply that to 125 ml, 1 hour. Now I know it says 125 ml per hour, but for us to use the unit cancellation method, we are going to write it like this. In this way, we're able to cancel mLs and we're going to be left with hours. So 1000 times 1 divided by 125, that will give us 8 hours. You're to give an insulin drip at 20 units per hour. On hand is 250 ml of NS with 100 units of insulin. What rate will your IV pump be in ml per hour? So what is this problem looking for? ml per hour. Now let's plot in our given numbers. 20 units per hour times, on hand is 250 ml in 100 units. So we can put 250 ml over 100 units. And we get to cancel units. And now we are left with ml per hour. So we're going to do our math. 20 times 250 divided by 100. That will give us 50 ml per hour. Patient is to receive 500 ml NS over 4 hours. If the drop factor is 10 drops per ml, how many drops per minute should be delivered? So what is this problem looking for? Drops per minute. Now let's plot in our numbers. So 500 ml over 4 hours. Now we have to consider what the problem is looking for. It's drops per minute. What we have here is hours. So the very first thing that we're going to do is convert hours to minutes. So 1 hour is equal to 60 minutes. We're going to write it 1 hour is equal to 60 minutes. Now we get to cancel the unit hour. Now we have ml per minute, but what the problem is looking for is drops per minute. So we have a drop factor of 10 drops per ml. So we can use that to convert ml to drops. So we're going to put multiply. We're going to put 10 drops per ml. So we're going to cancel ml. Now we are left with drops per minute. Now let's do our math. 500 times 10 divided by 60 times 4. This will give us 21 drops per minute. And that is how you use unit cancellation method for drug calculation. That is it for today, guys. I hope you guys found that video helpful. And remember this, the key element in being successful in drug calculation is practice. So go out there and do a lot of math problems using what you've learned in this video. Once again, hit the like and subscribe button. By doing this, our videos will go straight to you. But don't forget to hit the notification bell button so you guys get notified when we upload new videos. My name is Don, Mint, signing out.